Hello everyone. Let's discuss a very important concept of, and we can say very important question of binary search. And we will learn a very new concept. We will learn a new concept of checking in binary search through this question. Okay. So we have been given name of the question is minimize maximum of array. Okay. So we have been given an zero indexed array nums comprising of n non-negative integer. What is non-negative integer? Means greater than or equal to zero. Okay. And in one operation what we have to do is that we have to choose an integer I such that I is greater than or equals to 1 and less than n. And since we have zero based indexing, and why we are choosing from I, because I have to increase from the previous increase the previous element by 1. So if it is 0, then if I is 0, obviously it would be minus 1 index, and it doesn't make sense. Okay, that's why I is from 1 to n. Okay, so we have to decrease nums I by 1 and increase nums I minus y minus 1 by 1. Okay, so we have to return the minimum possible value of the maximum integer of nums after performing any number of operation. We are not restricted in terms of operation performed. We can perform any number of operation, and we have to tell the minimum possible value of the, basically we have to minimize the maximum integer in the number array or nums array. Okay, after performing the operation. So let's first discuss this example. It is 3716, and this can be the answer is 5. Basically what it means that in the final array nums, the maximum integer will be 5. Okay, and you can see choose I is equals to 1, the nums will become, if I choose I is equals to 1, then obviously I can just make it is 6 in the one operation. Means what I have told you, I have to decrement I by minus 1, decrement I by 1, nums I by 1, and increment nums I minus 1, which is basically 3 by 1. So it will become 4 6 1 6 in one operation. Okay, then still it is less than 5, so I will have to perform the operation, so it will become 5 5. Okay, now I will perform on this. Okay, now I will perform this, so it will become 5 and it will become 2. So now we have got our answer, in which the maximum number is 5. Okay, so that was this for this example. So how to solve this problem? Okay, how to get intuition behind the problem. uh, One thing you should learn the concept is that the number, suppose I am checking for mid. Okay, suppose I am checking for the maximum element mx, means in the final array I am assuming that the maximum element will be mx. Okay, now can I say that all the numbers which will be greater than mx, I can make it mx, and whatever is the remaining, means here the remaining is 1, if mx is equals to 5, I will just pass it to its left element. Why? Because obviously I, what the operation says, nums I minus 1 को हम लोग को increase करना है and nums I को decrease करना है. Okay, so I can say that I will just pass the remaining to its left. Basically I am saying that I, the intuition is that I will use the elements which are less than the mx as a sink. What the sink means is that whatever the remaining from the numbers which are greater than mx, I will collect their remaining into myself. Okay, until I am I am myself become greater than mx. Okay, and okay, so suppose this is the example, 8 6 7. Okay, and here it is 3, and suppose I am checking for 5. What I can say is that if I check for 5, so what the remaining will be here, it will become 5 and I will pass the remaining here too, so it will become 8. Now from this again I will make it 5 because it is greater than 5, and just pass the remaining, which is 3, to here. So 8 plus 3 11, 8 plus 3 11, again I will make it 5, again I will make it 5, and just pass the remaining, which is 6 plus 9, so it will become 9. Now there doesn't exist any sync in the left of this element, so I am confirmed that I can't make all the means I can't make the maximum element as 5 in the final array, because the maximum element will be 9. Okay, so how can we make this? Means what will be the maximum element then? Okay, if I can say that if I just increase the mx, if I just increase the mx to 6, I will just try with 6. Can I make this with 6? Okay, uh, 3867, 3867. Now we would check for the mx is equals to 6. Why I am increasing? Because the remaining was why the element was not accepted, because the remaining was the sum of the remaining was very much large, which made the last element itself greater than the mx. Okay, so we would have to increase the mx so that the remaining from the every element would be minimized. Okay, so I would check for the mx is equal to 6. I guess 6 will also not pass. Let's check for the 7. Okay, so from the 7 there will be no remaining. Now from here there will be no yes, there will be no remaining, because it is itself less than 7. So it was a sync, it can be a sync, although it was not used as a sync, but it can be used if some element was greater than 6 also. Okay, suppose it was 8, it was 8, then this element was, suppose instead of 7 it was 8, then I can make it it to 7 and pass the remaining, which was 1, to it, and now it will become 7. Still it is safe because we have to make the mx as 7. Okay, so now again I reach to this index, and now it again it is greater than 7, so I will just make it to 7, and the remaining I will pass it to the its uh, sync present in the left. Okay, so here it will become what? It will become 4. So I can say that I am able to make it as uh, the maximum element as 7. Okay, so now I also can prove that I can make it as 8 also. If you can see here, for 8 what? It is 7. Okay, 8 is 6, it doesn't matter at all. It is 8 and it is 3. So obviously the previously also the maximum element was it's 8 itself. Okay, so now can we make it now 9? Basically we can't make it. Or can we make it? No, we can't make it. We can't make it as 9. Okay, so one thing I noted here is that the numbers which I can make will lies between the lowest element of the current array to the highest element of the current array. Okay, and I can prove the monotonicity of this function. One thing you have seen that when I try with 5, I was not able to perform. Means I was not able to make the maximum element as 5, but I was able to make it with 7 and 8. Okay, so within the range, means suppose I binary search for a range L to R, I was able to do for some element, means from here to here I was able to make the maximum to that, but was not able to. So this is the property of monotonicity. So that's the, from there I came up with the intuition of binary search. Okay, So I will also use this in the code itself. So what would be the range? What would be the range? So the lowest would be, let's lowest is equals to 1e9 plus 7, and high is equals to minus 1e9 minus 7. Okay, and there will be a mid and answer is equals to 0. Initialize it. Now for auto ampersand it nums, what I will do, I will just take the minimum of all this. Low is equals to minimum of low comma it, and high is equals to maximum of it comma high. Okay, now one thing, while low is less than equals to high, what I will do, I will calculate mid is equals to low plus high minus low by 2. Mid denotes the maximum element in the final array. Okay, so for int I is equals to n minus 1, I greater than 0, I minus minus, I will start from the right to left, and if ai is greater than, sorry, one thing I forgot. Since for each of the mid value you will be changing the value of a nums, so basically we would have to make another array. Okay, we would have to take help of the another array. And why I am taking as long, because when I will just pass the when I will just pass the value, remaining value from one index to the previous index, then there might be a situation that it will just go out of bound. Okay, because the uh, AI is very large, can go up to 10 to the power 9. Okay, and there can be 10 to the power 5 elements, so in the worst case it can be somewhere between 10 to the power 14, so that's out of bound of integer range. Okay, that's why I am taking as long. And even this also I will also make the elements of the nums itself as long. Okay, now before before the query, what I will do, for int I is equals to 0, I less than n, I plus plus, I will just assign it to it nums I, because each time if I just use the nums without using another helper array, then we can see that if ai is greater than mid, then what I am doing, ai minus mid plus 1 is equals to ai minus mid. You can see here that I am modifying the array itself. Okay, I am modifying the previous elements, so for the next call of mid, we would not be performing the operation on the initial array, we would performing the operation on the modified array. That's why I have keep a copy of nums array each time. Okay, and I will assign ai as mid. Now finally I will check if a of 0 means the last available sync. If it is greater than mid, obviously it is violating the condition that the maximum element is mid. Okay, so what I have done, if it was violating, just uh, remember that when I was not able to do 5 as the maximum element, then what I have done, I have just increased the mid value. Low is equals to mid plus 1, just I have tried for the greater element. Okay, else if it is holding the condition, then this can be my answer. Okay, and finally I will return it, return answer. Let's run it. Sorry, I have not declared n. Yeah, it is giving right answer. Let's submit it. So it got accepted. So let's discuss the time complexity. The time complexity is obvious, quite obvious that the binary search is taking log n, and in each iteration, in each call of the mid, we are just running a loop for n times, so it will be big O of n log n. And space complexity, I am using another array a, so it will be big O of n space complexity.